Okay, so I quickly wanted to go over parts of the periodic table just in case the two videos themselves weren't clear. So I could put this together as another ed puzzle, but you've already had several this week. So if you're needing help understanding the assignment and figuring all of that out, let me quickly just go over what the periods and groups are and what they mean very quickly, so that you can go on ahead and get started knocking out that assignment this week. So obviously, we're talking about the periodic table this week, how it's arranged, how it works, all of the things that you need to know. Now, there are two main ways, well, really three main ways that this table is organized. Number one, it's organized by the number of electrons in the outer shell of the atom, the element, whatever it happens to be. It's also arranged in the number of electron shells each element has. The final way, and this is kind of a result of the other, two criteria, is that from the top left going down to the bottom right of the table, you get larger and larger and larger in size, or more massive. You're getting more and more particles as part of your element. So hydrogen has one proton, but if you go down to the bottom right, you have things that have 118 protons. So they're much heavier or much more massive. So that is how this thing is arranged. Now, to quickly go over the arrangement and what we mean by period, you can see here on my screen, I've circled all of the different periods in green. So period number one starts with hydrogen and it ends with helium. There's only two of them. And hydrogen and helium both have one electron shell. That's it. They have either one electron floating around or two electrons floating around and a single shell around the nucleus. When you get down to lithium and beryllium and boron and carbon, nitrogen, oxygen, fluorine, and neon, all of those in period two, well, now you have two electron shells. You go down to sodium, well, now you have three electron shells, and all of those in that row. All of them in period four have four electron shells. So that is one of the ways we organize this table. So you can see that's quite a bit of information you're being given just by how we stacked this thing together. Now, the next part of this is when we look at each column, and the easy way to remember rows and columns is columns are what hold up all the old Roman structures, right? Those big columns, and they're straight up and down. And then rows, like, in a movie theater, are the ones that are flat, right? You can't sit on a column. It's standing straight up and down. But if you knock that column over into a row, you can sit on it. So maybe that helps remember it. Maybe that was just dumb. I don't know. That's how it helps me remember it. So in the groups, or the columns here, what you have is an arrangement based on how many electrons are in the outer shell. So hydrogen has one shell and it has one electron in that outer shell. And if you look at lithium, lithium has two rows or two electron shells, but that outer electron shell only has one electron. And sodium has three electron shells, and the first two are completely full of electrons, but the outer shell still only has one electron. And you can see up here, I put these little arrows with a corresponding number. You may want to screenshot this. It might help you with this coming assignment. And in fact, I might attach this at the very bottom to help you out. But each one of these arrows lets you know how many electrons are in that outer shell. So for all of the ones starting with hydrogen and ending in francium, all of those have one electron floating around the outside. When you get to beryllium, all the way down to radium, all of those have two electrons floating around the outside of the shell. Over here at boron, that's three electrons floating around the outer shell. Carbon, all the way down to element 114, flerovium. They all have 4 electrons floating around in their outer shell, right? So the cool thing is this grouping here, the groups, based on how many electrons they have out there, that determines how many different elements one atom can bond to. So carbon can have 4 hydrogens attached because it's missing 4 electrons, and it borrows 4 electrons from 4 hydrogens, so they connect to each other. So these numbers up here that I have for you on this part, it's really useful information for how these things are going to react with other elements. And because everything in row 4 is missing 4 electrons, they bond in a similar way. They have similar characteristics as a result. So because of this, now everything in group 4 pretty much has similar characteristics. Everything in this group right here, the nitrogen group, they all have very similar characteristics to one another. And all of that has to do with the fact that it has 5 electrons floating around in its outer shell, and it needs 3 to complete its shell. So we're going to get into that stuff in a little more detail when we go into chemical reactions, which is either next week or the week after. But that kind of gives you an idea of what I'm talking about. So I can quickly go through this. You can see the hydrogen all the way down to francium, that's the first group. Alkali metals, all of them have 1 electron in that outer shell. You'll notice lithium is full here with its first shell, but its outer shell, it just has that 1 floating around. And sodium's first 2 shells are completely full, but its outer shell, it just has 1 electron floating around there. Same thing with potassium, so on and so forth. Because of this, because they only have 1 electron, they're actually really willing to give that away as fast as they can. So they are highly reactive, and you will never find lithium or sodium, can't say never, but you very rarely find these things pure in nature. They're generally always latched onto something else, another atom, because they want to share their electron, get rid of it. So they're very highly reactive. But then when you get to, say, the alkaline metals, which is beryllium all the way down to radium down here, well, they have 2 electrons floating around the outer shell, and they still want to get rid of those 2 electrons, but it's harder to find somebody, another element, looking for 2 electrons. So they're not as reactive. But they all have, again, similar characteristics. You get into the boron group or the boron family, and all of those have 3 electrons floating around the outer shell. And as a result, they're a little less reactive than the 2 previous groups that I just talked about. They have a lot of different characteristics, which you can see there on the screen. I'm not going to go through them because that's not really the point of this. I really just kind of wanted to point out, like, these are arranged in that manner. And because they all have the same number of missing electrons in their outer shell, they react the same. And I wanted to give you a couple of quick visuals there. So hopefully this kind of helps you out with this week's assignment. The one last thing to mention is because the noble gases have complete outer shells, they don't react with anything. So you can suck helium in your mouth and talk really funny like this, and it's not doing anything to you. It's not going to react with you in any way, shape, or form, because those atoms, they have everything they need, and they're not looking to get rid of their electrons. They're not looking to share with anybody else. So the noble gases, well, they're the noble gases because they don't need anybody else. They're royalty, right? So, all right. Anyways, hopefully this clarifies what the other video was talking about and helps you out. All right. Done rambling.